right, here's an ambitious question. Quite challenging.
Not for a hard word.
Okay. Not for faint of heart.
That's not hard word. That's cool.
Our worst word.
Hard word has to be dominant. It's for your gender.
Okay, so let's think about the partial fraction expansion needed for this one. What would you need?
Wouldn't you have to see if you could,
Well, I have this one. Oh, by the way, this one cannot be factored.
oh, then you have
If
to
you
do-
can't factor, what do you have to do?
complete the square.
Complete the square. You have to complete the square. But, okay, let's do that, yeah. So, if you complete the square, what goes inside the square? X
Minus, plus 3.
plus 3, because half of 6 is 3. And then 3 squared plus what gives you 34? 3 squared is 9. 9 plus what gives you 34? 25. Okay. And then the other ones are, because of this, what do you need?
X minus 2.
And then what else?
X minus 2 squared.
Yes. You need that.
You could keep the first one together though and do the ax plus b, right?
Yeah, so this one is a quadratic one, so the numerator must be
Ax plus b.
ax plus b.
But you could just keep it together instead of completing the square. Right?
Oh, I see. You just leave it like that. Well, eventually, when you integrate, you will have to complete the square. So I'm just doing it early. But yes, you're right. You don't have to rewrite it at this point. You can just leave it, and then only later you can complete the square.
Right.
But doing it this way makes the calculation slightly easier. Not by a lot, but just a little bit. Okay, and then since it's a first degree 1, you put C, and then although this is degree 2, there's already this one, so you still just put D. So when you have a quadratic one, you put ax plus b. Linear, you put one letter, and even if it's like higher order, if the lower orders are there, you just still put one letter. If this had a square, then you would put cx plus d and so on and so on. Okay. All right. So now let's try to find this out. And what we're going to do is, since both sides have what I want to do is I want to multiply this here, 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 and here. Because if I do so, all the denominators will get canceled, will be destroyed. And we want to do that because denominators are our enemies.
Evil.
Yeah, they're evil. Those are the ones that torment us with like, all these other rules about fractions. So we want to get rid of the fractions by destroying the denominators. Okay. But then, well, first of all, the left side would be 15x squared minus 20x plus 5. And then ax plus b, because this portion is same as this one, when this yellow thing gets multiplied,
X minus 2 squared. X minus 2
you'll just get x minus 2 squared. Yes. And then c times what? C times
C is going to be
still x plus 3 squared plus 25 will survive. This is same as this one. This will survive, and one of the x minus 2 will cancel away, so we get x minus 2 here. And then d times this is what I get. Okay. What should I plug in? 2. Why?
have it in there already.
There's x minus 2. X minus 2. What happens when you plug in 2? Becomes 0. So the calculation becomes really easy, right? So we plug into 2 squared is 4. 4 times 15 is 60. Minus 2 times 20 is 40. Plus 5, so it'll be 25 on this side. And then when you plug into it will be 0, this will be 0. 2 plus 3 is 5 squared. So it'll be 25. 25 plus 25 will be 50. So you get d times 50. And it's really easier to plug in 2 in here than this one. Although they're the same functions, if you plug in 2 here, then you have to calculate more. So that's what I meant by having it this form. Slightly saves time. Now you divide both sides by 50. What do you get for d? d is 25 over 50, which is 1/2. Now what should we plug in? Any suggestions?
We can try 0.
Yeah, the thing is, we already ran out of good numbers to plug in.
-3.
Okay, well, -3 might be slightly better because you get 0 here, 0 here, except that it doesn't really get rid of everything. Well, let's try x equals to -3, but then we'll try x equals to 0, okay? So if you plug in -3, that's 9 times 15, that's 135. Oh, it's really, this is a, 3 plus 60, 195, it's 200? No, can't be sure. 9 times 15, that's 45 times 3, 25 times. I have to do this, okay. I mean, I think I know the answer, but I don't want to mess it up because then everything else will be different, wrong.
Do you need a calculator?
Nice joke. Okay. Okay, so yeah, indeed, this is 200. I thought so. Okay. All right, so that's going to be 200 on the left side. Okay, and then you plug in -3. -3 minus 2 is -5. Squared is 25. But you also have to plug in -3 here. So it's -3a plus b. X replaced by -3. -3 minus 2 is -5 squared is times 25. Okay, and then -3 plugged in here will make that 0, so it'll be c times 25 times -5. And then -3 again plugged in will give you d times 25. Okay, thankfully every one of these are divisible by 25, so let's just go ahead and divide both sides by 25. $2 is how many quarters? 8 quarters? So 200 divided by 25 will be 8 on the left side. -3a plus b minus 5c plus d. So that's what we get. And then when you plug in 0, you get 5 on the left side. When you plug in 0, that would be b times 4b. And then 9 plus 25, it's really going to be 34 times, so it'll be -68c. And when you plug in 0, that's 34d. Okay. Now now we really run out of numbers to plug in. I mean, you could still try plugging in like 1 or -1, but it's really ugly. Yes?
Where did 5 come
5, if you plug in 0 here. If you plug 0, you get 5 on the left side, and I plug in 0. Okay, so I really don't like plugging in more numbers. Yes?
I was just gonna say, I think yesterday we, I forgot how we did it, but like, never mind.
If you think about how we did the previous questions, there is actually another thing that we didn't make use of. Yes?
Why can't you just leave the one you're trying to find on one side?
Uh-huh.
And make everything go on one side. And
That's how you're going to solve, but here's the problem. How many unknowns do we have?
2.
No, we have A, B, and C. We found D, right? So we have A and B and C, but we only have 2 equations.
Can't we just,
well, we can
write one as,
Huh?
We can make A equal to an equation with B and C.
No, you don't understand. If you're solving a system and you have 3 unknowns, how many
Yeah.
equations do you need?
3.
3. How many do we have?
2, so you can't.
We
do
only
it.
have 2. We need another. Okay? In order to solve, you need more. You need exactly 3 in order to solve for 3. Okay? Okay, so going back, here's what we're trying to do here. We know that these 2 sides should be equal as functions, right? This should equal to this one as functions. And being equal as functions means that for whatever value you plug in, the left side and the right side should produce the same number, and that's how we got these equations, right? And we are trying to be careful with the numbers that we plug in, because if we put something hard, then you end up with a crazy looking equation which you don't feel like solving. So that's why we chose 2, because 2 will get rid of a lot of things. But at some point, we see that, oh, sorry, I should really have said here that I'm plugging in x equal to 0 to get that. So we plugged in x equals to 2, x equals to -3, and we plugged in x equal to 0. And that's not enough. But then there's another way to get this, which is you can expand everything. And because A, B, C, D are numbers, you can collect the like terms. What would be the order of the polynomial you get? What would be the degree of the polynomial you get? If you expand this, what's the degree of the polynomial? Huh? 3, because you have x and x squared multiplied, you get x cubed, right? So you have a cubic polynomial on the right side, and then you have another polynomial, this is quadratic. And for the 2 polynomials to be equal, you need all the coefficients to be equal. Yeah. So if you have 2 polynomial functions, when can they be equal? If all their coefficients are equal, then we know that they're equal. Right? So that's another thing we can do, except that we really don't want to do it. Like, do you want to expand this? Nah. Yeah. So you don't really want to expand it, but you just want to dream of expanding it. And then try to see if that works. It's like you want to have a cake, so you have to bake a cake, but that's just too much work. So you dream of baking a cake, and then if you dream hard enough, then you can taste it. I don't know. Something like that, yeah. All right. Here's what we're going to do. Imagine that you expanded this. What will be the cubic term that you get out of here?
AX cubed.
AX cubed, right? The only cubic term you're going to get from here will be AX and times X. So you're going to get, AX times X squared. So it will be AX cubed. That's what you're going to get from here. What will be the cubic term here?
CX cubed.
Yeah. So this one will be
CX cubed.
CX cubed. what would be the cubic term from here?
There is none.
There is none. The highest order is just x squared. So imagine that you did all the work. Then what would be the cubic term that you end up writing? These are like terms. Yeah, it would be
AC x cubed.
a plus c x cubed. So you will get a plus c x cubed plus something something. Right?
Yeah.
That's what you're going to get. And that has to match with the left side, but do you see x cubed term here?
Yes.
No, there is no x cubed term. So what does that mean?
Equals to 0.
It must be 0. They must cancel away so that the right side is a quadratic polynomial, or else we can't have a quadratic function to be same as a cubic function. No way, right? So this one should really correspond to the left side, which has 0x cubed. So
So you're
good.
saying we can only focus on the cubes?
No, I mean I'm too lazy to do the work, so I'm just looking at the cubic term.
Oh.
But wait, isn't this an equation? We just decided that 0 is equal to a plus c. Right?
Yeah.
That's an equation, right? Now, how many equations do we have? 1, 2, and 3. How many unknowns do we have? A, B, and C. 3 of them. D is 1/2. That we already know. Okay? So that means we can solve it. Okay, so let's solve it. How do you solve such a thing? Well, you solve it by solving for one of the variables. So just subtract c to the other side, so a is equal to negative c. Plug that into one of them. So this will now turn into a equals to negative c times negative 3 will be positive 3c plus b minus 5c plus, let's say, 1/2. D is 1/2. Move the 1/2 to this side. 16 over 2 minus 1/2 will be 15 over 2 equal to b minus 2c. Okay, so that's the equation that this becomes. Now for this one, if I put 1/2 here, that's 17. Subtract, that's going to be negative 12 equals to 4b minus 68c. That's after plugging in 1/2, right? Oh, but then you see that every one of these numbers are divisible by 4, so let's divide by 4. Negative 12 divided by 4 is negative 3. 4b divided by 4 would be b. 68 divided by 4 would be 17. Then you subtract. Okay. Why do I want to subtract? Because then b minus b is 0, so they cancel away. Negative 2 minus negative 17 gives you positive 15c. Plus 3, 6 over 2, 21 over 2. And therefore, if you divide by 3, that's 7, 7 over 10. So you get c equals to 7 over 10. Plug that back in here so that you get 15 over 2. B minus twice of 7 is 14 over 10. Move that to the other side. This is 5 times 15 is 75 over 10. 75 plus 14 is 89 over 10. So B is equal to 89 over 10. C is 7 over 10. And then A is negative of C, so it's negative 7 over 10. Okay. So we got all our coefficients. Are we done? Is that the answer?
No, you integrated.
No, this was just to get the partial fraction expansion, and now we have to do the integral. Let me just delete everything. Okay, so here's what we wanted to do. We wanted to rewrite 15x squared minus 20x plus 5 over x squared plus 6x plus 34 times x minus 2 squared equal to, you get negative 7 over 10x. It's ax plus b. B is 89 over 10 over x plus 3 squared plus 25. I'm going to rewrite 25 as 5 squared. Okay, plus c is 7 over 10 over x minus 2. And then d is 1/2 over x minus 2 squared. Now because these two are equal as functions, they're exactly the same functions, integrating this function is same as integrating this function. Okay. Now, both of these have 10 in the denominator. Let's factor that out. So you have 1 over 10 integral of negative 7x plus 89 over x plus 3 squared plus 5 squared dx. And then you'll have to do the integral of 7 over 10, 1 over x minus 2 dx. And then you'll have to do the integral of 1/2 of the integral of 1 over x minus 2 squared. Now these two integrals are relatively easy to integrate, right? What's the integral of this one? ln of the denominator, because it's f prime over f type, right? If you integrate f prime over f, then the answer is ln of the denominator. So we can use that to say that this is ln x plus 2. Whereas this one, we can rewrite it by writing it as x minus 2 to the negative 2 power. So let's do that. Right? Let's rewrite this as x minus 2 to the negative 2 power. Because then you can use the power rule. You add 1 and put the reciprocal in front. So those are easy. This one's not so easy. This one requires some work. So we're just going to work on this one. And to do that, we need two things. One is I'll be giving you the following formula during the exam. A squared plus x squared dx. This gives you the arctan as the answer, right? 1 over a arctan of x over a plus c. So we will need this formula at some point. And additionally, we will need to do a u substitution for this one. So when you do the integral of 1/10 of negative 7x plus 89 over x plus 3 squared plus 5 squared dx, you want to set u as this thing here, x plus 3, so that dx is equal to, no, if I differentiate the left side, du is equal to just 1 times dx, right? And if I solve this for x, x is u minus 3. Let's do the change of variables. I replace x by what? U minus 3. I replace x plus 3 by u squared. And And then dx is replaced by, dx is same as du. Okay? So we've managed to do the u substitution. Let's simplify before we integrate. This will be negative 7u. Negative 7 times negative 3 is 21. 21 plus 89 would be 110 over u, oh, that's right, like, well, u squared plus 5 squared. How do we integrate this? Like that, right? Heart shape. We split it like that. And let's pull out the negative 7 after splitting. So negative 7 over 10 integral of u over u squared plus 5 squared. And then this one will be 110 divided by 10, which by the way is just 11. And then you integrate, and let's write down 1 over. We'll switch places so that we can use that formula, okay? I'm going to put 5 squared first, then put u squared du. All right, how do you integrate this first one?
You needed 2 at the top, so
Yeah.
you need to put a 2 there. And then
Why do you need a 2 on the top?
Because if you differentiate the
If you
bottom-
differentiate the bottom, it's 2u plus 0, right? And if we had a 2 there, then it would be f prime over f, right? So we would wish it was a 2.
But you have to divide outside.
Yeah, but you can't just put 2 because you want it. You have to counter it by putting a 2 in the denominator so that they cancel and it's okay, right? So we didn't change the problem. We just changed the looks, right? I put a 2 there and divide by 2, so nothing is changed. But this is now f prime over f type, which you can integrate. So it'll be negative 7 over 20 times ln of the denominator. I'll just put 25. And by the way, because u squared plus 25 is always positive, we don't need the absolute value. Plus, this is just 11. And then we apply that formula up there. And because this is 5 squared, it would be 1 over 5 arctan of u over 5 plus c. And then remember, u is x plus 3, so you also have to plug that back in. But overall, that's going to be the answer for this first part. Okay? So we are going to get negative 7 over 20 ln of, well, x plus 3 squared plus 25 is this part right here. That's where that came from. So we can just write that, x squared plus 6x plus 34. And then you have 11 over 5 plus 11 over 5 arctan of x plus 3 over 5. And these two are from the first integral. The second integral, we already discussed, it's ln of the denominator. And this last one, well, what do you have to do? You add 1 to the exponent, which is x minus 2 to the negative 1 power. And then you put the reciprocal of that in front, but that means you're dividing by negative 1, which is same as introducing a minus sign in front. Plus. So that's the final answer.